Welcome to our Eastview Institute tutorial covering the fundamental theorem of calculus, part 2. I'm Andy.
I am Ethan.
And I am Eric. So, if you're watching this video, you should be familiar with the fundamental theorem of calculus, part 1, which states the following. Every continuous function is the derivative of some other function.
Continuous functions have an antiderivative, but it does not state that you can find it.
The process of integration and differentiation are inverses.
So, moving on to the good stuff, part 2 of the fundamental theorem of calculus. This part states one big thing, shown here. That is, if f is continuous on the interval a to b, and f major is an antiderivative of f, then the integral from a to b of f of x dx is f major of b minus f major of a. Any definite integral of any continuous function can be found with an antiderivative.
So what this means is if you have a graph of f, shown here, and take the integral of f from a to b, we get a graph that looks like this.
And if we took the antiderivative of f, which we'll refer to as f major, then f major of b minus f major of a is the same as the integral.
So we'll move on to our first example problem, 1 over x, where we will take the integral of 1 over x from 1 to 3. The antiderivative of 1 over x is ln of x, so the integral we want to take is ln of x plus c from 1 to 3, where we plug in the 3 and the 1 into our equation. So we have ln of 3 plus c minus ln of 1 plus c. The c's will cancel and ln of 1 is 0, therefore we get ln of 3. The c's will always cancel due to the negative sign, so there is no need to actually write them. And so after we get all this, this is the graph that actually represents the equation that we actually found here.
Moving on to our second example problem, we are having the sine of x. Now, if we take the integral of the sine of x from 0 to 2 pi, we can find that the antiderivative of sine x is negative cosine x. If we plug in 2 pi and 0 into negative cosine x, we can get the answers negative 1 and negative 1. Because we are subtracting these numbers, the result is 0, meaning that the area under the graph of both humps of the sine x curve results in 0. If we look at the graph shown here, we can see that this matches.
Now that we've gone over 2 examples, here are 3 for you to try on your own. These are similar to the book problems, and if you have any troubles, ask fellow students or Mr. Haug. For your first question, you'll be taking the integral from 0 to 5 of x cubed dx. For the second, you'll take the integral from 0 to 4 of x squared minus 2 dx. And for the third, you'll be taking the integral from 0 to 2 pi of 1 minus cosine theta d theta.
So in summary, we've covered the practical use of an integral, how it relates to graphs, and what an antiderivative is and how it's used.
Remember the main points of the fundamental theorem of calculus, part 2. That if f is a continuous function on the closed interval a to b, and f major is the antiderivative of f, then the integral from a to b of f of x dx is equal to f major b minus f major a, or the integral of f.
With skills like these, you may one day be able to take the integrals of such sexy equations like this. But that is for another day, so for right now we must all wish you goodbye. So,
Bye!